children, welcome to Evolve Science classes. Today we are discussing the different formulas that are used in the chapter Motion for class 9. The first formula is how to find out the velocity. The formula is distance upon time. It's written S here. This is something printed mistake. So it is distance divided by time. We denote it as S divided by T. From the given formula we can also find out two more formulas, that S is equal to V into T or T is equal to S upon V. So from if in a question you are given velocity and time, you can use to find out the formula by getting the distance. And if you are asked to find out the time, then you have to use the distance and the velocity given. Average speed is calculated by total distance divided by the total time taken. Total distance denoted here S1, S2, S3 divided by T1, T2, T3. S1 by T1 is nothing but V1. S2 by T2 is nothing but V2. Similarly, V3. So average speed can also be calculated. If we are given three velocities, we can also calculate the average speed by the addition of the three velocities by the number, how many number of velocities are given. Here we find is V1, V2, V3, so three velocities are given. Suppose it is V1, V2 plus V3 and V4, then we will write divided by 4. Velocity is the speed with direction. It is discovered or it can be calculated by the formula displacement upon time. So the next formulas which we are going to see here are average velocity. Here the average velocity is the change in displacement divided by time. Average velocity is change in displacement divided by time. It can also be calculated by the formula u plus v divided by 2. U is initial velocity and v is the final velocity divided by 2. Another topic is acceleration. Acceleration, when it is in uniform, it is an uniform acceleration, we find it by change in velocity divided by time. Change in velocity, it's v minus u upon t. Two types of velocities are there, initial velocity and final velocity. Whenever we say change in velocity, then we do the subtraction from the final velocity to the initial velocity divided by time. Acceleration, if it is negative, we call it as deceleration, or it is also termed as retardation. The same thing, change in velocity by time, but here acceleration will be denoted by minus a and the unit will be meter per second square. Now for the chapter motion, some of the calculations are also done by graph. For formulas to be derived from the graph, for speed time graph, we use this here. Time is taken to the x-axis and speed is taken to the y-axis, or velocity can be found out. When we are finding out this, then the right angled triangle, we find it at right angled triangle, perpendicular upon base, this is the perpendicular and this is the base. Perpendicular upon base will give us this slope, that is which we term it as the speed or velocity. So if a graph is given like this and this is the speed, AO is the speed, then this is the t time and this is the velocity. So to find out the OA slope, we will do it as perpendicular upon base. Perpendicular is AT and the base is OT. Whatever numbers are given, you have to use it and divide it, get the value. Acceleration is also find out in the same way. For uniform acceleration, we draw the line like this. This is velocity on the y-axis and t on the x-axis. To find out acceleration, we use this slope OA and we draw dotted lines to find the perpendicular, then AT by OT will give us OA, that is acceleration, and it is always measured in meter per second square. The next formulas for this are distance traveled. Suppose we have to find out the distance traveled in this graph, the entire distance traveled from here to here, O, T and V. We have to find out the distance traveled. So what we have to do, again we have to draw a perpendicular line, but this time we will find the area of the right angled triangle. What is the area of the right angled triangle? Half base into height. This is how we find the distance. This will give us distance. Similarly, in the other graph, if it is found like this, the graph goes like this. The graph goes like this and we have to find the distance here. Then it is NMTR. NMTR is a rectangle seen here. So we have to find the area of the rectangle, that is length into breadth. In the same way, if NMTR is not a rectangle but a square, if suppose the graph forms a square, then we have to find the area of the square, that is side into side. In another case, if the graph given here is somewhat like this. If the graph given here is somewhat like this, let me draw it for you, like this. It's going like this and here. The graph is like this and you have to find out the area or the distance traveled from G, H, N, O. You have to find the distance traveled from G to H. So what you do, you will draw these lines to the time axis. This is the time axis and this is the velocity. So you draw it for GH. You are supposed to find out the distance here to G to H. Then for this entire area, you have to find the area. This is GHON is a trapezium. GHON is a trapezium. And to find out the area of the trapezium, we use half sum of parallel sides into height. Here the sum of parallel sides is GN plus HO. These are the parallel sides. This is one parallel side, this is another parallel side. Into height. Height is NO. Here the height will be taken this, not the slope. Never do this. It will be wrong. So H will be NO. And then you have to calculate and find out the entire area of the trapezium. The next one here. To find out the speed of a vehicle on a circular path. Suppose this is a circular path of some radius, say R. And you have to find out the movement of the vehicle from A, starting from A and coming back to A. Then the velocity is denoted as 2 pi r upon t. Pi, it can be taken as 22 divided by 7 or 3.14 as is the requirement of the numerical. If you are given diameter, then you have to make it into radius, that is d upon 2. And then you can find out the velocity by this formula. The chapter has 3 very important formulas which you should remember by heart. One is V is equal to U plus AT. This is called as the first equation of motion. Then the second equation of motion is, this is V is equal to U plus AT. Second is S is equal to UT plus half AT square. UT plus half AT square. And the third is V square is equal to U square plus 2AS. These are the three basic equations of motion which you need to formulate whenever you are doing any numerical. Now, suppose you are given all the variables. Variables means whatever is given in the question of the numerical. Which formula will you use? How to get to know very quickly that which formula you have to use. So first write down the variables and see if in the variable the s is missing, that is distance is missing, no distance is there in the variable, then just use first equation of motion. For next question, next type, if in the equation time is missing, time is not there in the variables, use this one. And if in the question you find that both distance and time are given, not missing but given, then use this one. These are some of the very important points which you should keep in mind while you are doing the equations of motion and for the numericals of the chapter motion. Thank you.